asked you to do page 69 and 70. So if you're looking at page 69, here's a product rule. And if we look at it, notice that when you're multiplying two radicals, your indexes need to be the same. And then your result, your index, is the same as it was. Also, if you look where the outside numbers are, they get multiplied and they stay on the outside. And the inside numbers, the radicands, get multiplied and they go inside. And so just double check, did you multiply everything okay? Quotient rule basically separates two radicals. As long as they have the same index, you can write them top and bottom separately, or you can squish them together into one big old radical. And so I would encourage you to do that with 7a and 7b. Now, if you've done number 8 and simplified, notice that square root of 4 ends up to be 2. And so now we can just have 2 times square root of 3. Yes, we could have done square root of 12, but we could also do this. And this is just simpler. For number 12, I wanted you to write square root of 12 as the product of two radicals. And here I wrote square root of 4 and square root of 3. I want you to think about what would happen if I use square root of 6 and square root of 2 instead. Because when you multiply that, that's still 12. And so that would be okay, an okay way of writing square root of 12. But notice it doesn't give you then a simpler form. You can't take the square root of 6 and you can't take the square root of 2. So you wouldn't be able to still do something there. Let's see, if you did 13 correctly like that and 14 as well. 16 and 17, you can look at cube root of 8 ends up to be 2. Cube root of 5 you can't do, so it's just like that. I did make an error there. That should have been a 4 for number 17. And notice they all nicely simplify. Now for the rest, I'm asking you to write the prime factorization of the product. So go ahead and do that if you haven't already. So here is number 20 and through 23. And if you notice, if you broke down 40, you had 3 2's, and then it became 2 square root of, or cube root of 5. The 500 broke down to 3 5's, and when you saw it, there was a 5 on the outside, and you had leftover of 4. So the 96, and it's the 5th root of 96, and notice there were 5 2's. And then 3 leftover. Make sure your, my pen is fat, so make sure your index looks like an index. Here there's 4 2's, so there's 2 on the outside, and then the 4th root of 3. So that would be a leftover. So you should see that there is a correlation between the index and the number of the same number that's on the outside. So if there were 3 2's and 2 3's, and it was, let's say, the cube root, then these 3 2's would come out on the outside, and then these 2 3's would stay on the inside. So if it's cube root, Then we're going to circle groups of 3 at a time. And if it's the 5th root, we're going to circle groups of 5 at a time. 4th root, we're going to circle groups of 4 at a time. So let's practice some that aren't on or that aren't in your workbook. So here is another example. We have the square root of 45. And so if we're thinking about the square root, we're going to circle groups of 2 at a time. So if we have the square root of 45, let's break it down. We could, if we see it already, we can say square root of 9 and square root of 5, going by what we did before, breaking it up into 2 nice radicals. However, we don't always see that. So if we didn't see that, let's just break 45 down. 45 is 3 times 15. 15 is 3 times 5. Square root means I'm going to circle 2 at a time. So there's my 3. So that 3 is on the outside, and then the 5 left over is on the inside. And that's the same idea if I had square root of 9 and square root of 5. The square root of 9 becomes the 3, and then the 5 is just left over. So if we see the cube root of 54, I know it's even. So that's 27, 3, 9, 3, 3. The cube root means I need 3 of the same number to make a group to come on the outside. So that's a 3 on the outside, and then leftovers. Where do you put your leftovers after dinner? You put them in the fridge. And so all your leftovers are going to go back inside the radical can. So go ahead and try the square root of 180. Go ahead and pause it and then try it. So let's see. Did you get the same thing? I broke it down to 2 and 90, 3 and 30, 3 and 10, 2 and 5. And so this is a square root, so I'm going to circle 2 at a time. Here's 2 3s. Here's 2 2s. So what do you think this 3 and this 2 should be doing with each other on the outside? If you said multiply, you are correct. They came from multiplication, right? So it would make sense that they are still in multiplication. And then the 5 is a leftover, so it goes in the fridge. Now, if you relate this back, you could have broken it down into square root of 36 times square root of 5, because that's 180 if you multiply those together, and square root of 36 becomes the 6, and the 5 stays the square root of 5. So I want you to understand where it's coming from as well. So go ahead and try the square root of 40. You can see how that works. And if you broke it down to the 2 and 20, sorry, I'm having some technical difficulties here. So 2 and 20, and then 2 and 10, and then 2 and 5. Well, square root means 2 at a time. So this 2 comes on the outside, and then leftovers, well, they came again from multiplication, so it would make sense for them to multiply back together to become 10. So this one's a little trickier. I threw some X's in there, of course. So let's just do the 375, break the 375 down. 3 times 125. 125 is 525. And 5 and 5. Again, cube root means I'm going to circle 3 at a time, and the reason why I'm circling 3 at a time is because that makes a perfect cube root. And then I'm going to have a leftover of 3 to go in the fridge. And of course, I can't forget my index, which is 3 right there. X to the 7th. If you think about what that means 7 little x's, 5, 6, 7. And cube root means I'm going to circle 3 at a time. So how many groups is that? This one comes 1 out, and this comes another out. So that would be x squared on the outside with a leftover x on the inside. So sometimes it's helpful to write them all out. Y to the 12th, if you think about that. So you have y, I should have made this one the x's. If you have 12 little y's, think about how many groups of 3 you're going to get. If you said 4, you would be correct. And then there's no leftovers because you gathered them all. What about z squared? So z squared is just 2 z's. 2 z's. There's not enough of a group to come on the outside, so theirs are going to be both leftovers, and then this would be your answer. Go ahead and try the next one I have right here. Okay, so let's check it. 192, I know it ends in a 2, so 2 goes into it. Let's see, 86 times. Is that right? 96 times. Sorry, 96 times. Let's start over. 2 and 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So groups of 5, since it's the 5th root, so 1, 2, 3, 4, 5, all of those become the 5th root of 2, 2, 2, 2, 2 is 2 on the outside. And then I have a 2 and a 3 left over, so those go on the inside as 6. A, there's not a group, so I can't take any out. B to the 13th, if I had 13 little b's here, I'd be circling 5 at a time, so I'd get 2 of those groups with 3 leftovers to go in the fridge. And I can't forget my little index here. Make sure your index looks like an index and not an exponent. So be careful there. This is pretty sloppy. Okay, so now you should be able to do the rest of the workbook. Make sure you check your answers.